Hello, welcome Algebra 2 students. Just letting you know that this or tomorrow's lesson will be the last lesson of the whole school year. I did make a note on your homework assignment from Friday stating that starting today, I'm opening all the assignments from the fourth quarter. You can go ahead and do them. We'll keep in mind they are 10 points off from original grade. So that's because you've done it too late. A lot of you are missing maybe 2-3 weeks worth of work. That's going to be accounted for. But again, a 60, a 30, a 45 is still better than a 0. You'll have till this Friday, not next Friday, this Friday for my class, you have till 11:30 p.m. at night because I have to go back and grade everybody's late work from all 4 classes, and that's just more work on me. So Wednesday and Thursday, I will have a study guide for you. I'll have a PDF form, and I'll have it on there to answer. And that's to show you how, it's a study guide, so it's to help you to do your exam for your final exam. Your final exam will be next week. I don't know when exactly, I don't know how they're doing the days, but you will have it. It's between Monday through Wednesday. You'll have that time period to do the exam, and then I'll grade it there. All right, let's go ahead and get started with the lesson. We're going to go ahead and talk about solving exponential equations and inequalities. Here we have, if we have a, so the base is a, and it's raised to the x power, and it's equal to the same base a, and it's raised to the y power, that means the two exponents are equal to each other. They have to have the same base for the exponents to be equal to each other. So here, example 1a, we're going to solve for it. We're going to solve for it by solving for x by using this method up here. According to this, we have 2x here. We need the same base in order for us to find what x is. We can't take the square root of x on both sides and solve for x that way. We can't do it that way. But we can go ahead and change it. So I know for 16, I can get it in the base of 5 because 2 to the 4th power is equal to 16. So the first thing I would recommend is try to match up the bases. So is there a way where I can undo 16 and try to put it in terms of 2 to the whatever power? In this case, again, I have 2 to the 4th power. So when I do that, they have the same base, meaning it's the same number. That means x is equal to 4. Next one. So we have 9 to the c plus 2 power. We have 27 squared. For 27, so I have a base of 9 here. If I look at 27, we have to think of exponents. I know that 9 to the 1 power is 9. 9 squared is 81. So that means I can't use 9 as a base. But I can undo my 9 and put it as a base of 3. So I undo it. So to get 9, I can do 3 squared. But you have to include the rest of your exponent there. So I have the c plus 2. I'm going to multiply that into my 3 squared that I just changed. So for the 27, I can undo the 27 and I can have it as a base. I know the cube root of 27 is 3. So then I have my 3 cubed. And then I have my 2, I can't forget about that, and I'm going to have it there for my exponents. So now I have the same base. I can set the exponents equal to each other. So now let's go ahead and simplify. I use distributive property here. I have 2c plus 4 is equal to 6. Move the 4 over. 2c equals 2. c is equal to 1. So if the bases can't match up like number 1 or example 1a, then go ahead and try to find a base that they both have in common. Example 2, let's say, what if we can't have them to have the same base? So we have 200 and 100, or 1.05. There's no way they can have the same base. That's when we apply logarithms to this. So what we do, we have this type of problem, we solve for x. We go ahead and take the log of both sides, meaning we're going to have the log of 200 is equal to the log of 1.05 to the x power. If you remember about exponents for logarithms, if you have an exponent, you can move it all the way to the front of the problem. So I'm going to go ahead and move my x to the front. I have the log of 200 is equal to x times the log of 1.05. Remember, if it says log of 1.05, the base is 10, and that's something you can do in your calculator. Now, we can get the x by itself. X is now multiplying into that logarithm. I can divide both sides by the log of 1.05. And then I have the x by itself. When you do these type of problems, be careful how you put in your calculator. You can't put all the logarithms in your calculator to expect a right answer. Believe me, I've done that before, and I got a completely different problem. So here I did log 200, press enter. You have all these decimals. Then I divided it by the log of 1.05. So do not do log 200 divided by log of 1.05. You're going to have a completely different answer. Log of 200, enter. Divided by log of 1.05. And then you have about, x is being about 108.59. Let's look at b over here. So 7, 4, they don't have the same base. There's no way that they can have the same base. We can undo 4 and do 2, but 7 is already a prime number. We can't. That means we have to take the log of both sides. We'll do the log of 7, the 2y plus 1 power is equal to log of 4 to the negative y. We have exponents and we have logarithms. We can move them to the front. So in this case here, we have the 2y plus 1 times the log of 7. I'll move this a little closer. 2y plus 1 times a log of 7 is equal to negative y times a log of 4. Now exponents now become the number and I'm multiplying into it. Here we're trying to solve for y. We have to find a way to get the y's by itself. So here I have a binomial. I could go ahead and multiply the log to each one. I can't just subtract 2y and move it over to this side because it's combined with the plus 1. So I have to find a way for me to move it over completely. So if I go ahead and distribute, remember the 2y plus 1 is a number in front. It's not going to affect your 7 at all. So you're going to have 2y log 7 plus 1 times log 7 is just log 7. So then I have that, and this is going to be left the same. So now I separated it. When I separated it and does the parentheses, I can officially move the y over to the other side. If I have the y's on one side, I can factor out the y. Now, let's go ahead and subtract this. So remember, it's like terms. I'm going to go ahead and subtract both sides by negative 2y log of 7. Can't really combine them. They're completely different. So you have the log of 7 equals negative y log 4 minus 2y log 7. And now, the numbers in front, there is a common number here. You can factor out the y officially. So when you factor out the y, I end up with a negative log 4, and then I end up with a negative 2 log 7. So keep in mind that number you're factoring and you're moving over, it's always in front. You're never multiplying it with the base here. Now, we have this whole thing right here. I factor out the y. I can divide both sides by that whole factor. So negative log 4 minus 2 log of 7. Multiply both sides. And when I do, I have the log by itself, and I think what I did is I put them in decimal form. I tried putting this all on my calculator all together, and it really messed up the answer. I tried doing that, press enter, and then putting this. It gave me a different answer. So what I did, I combined the numerator, put it on the top. I got the log of 7 is about 0.84509. And I did negative log 4 minus 2 log of 7, so negative log 4, press enter. I did minus 2 log of 7. I ended up with negative 2.2922. You will get the different answer if you work it out all together. And now, when I divided, I ended up with about 0.37 as my answer for y. Example 3. Whenever you see an e, you always think of the natural log. Don't put in. You guys are putting in. It's ln. Natural log, so ln. Here we have that we have to solve for x. We have an e indicating instead of using log, we're using natural log, which you also have in your calculator. So first thing, taking the natural log of both sides. Now let's go ahead and start moving things around. If you notice here, the exponent is only being applied to the e. It's not being applied to the 6. So that's why I'm not going to move the x over to the front because it's only applying to the e. So let's go ahead and separate them. I know I can separate them because 6 and e to the x power, they're multiplying. When they're multiplying for properties of logarithms, you are adding them. So that means I'll have the natural log of 6 plus the natural log of e to the x power. Now, I can go ahead and simplify this even more. You could move this over, or one of the inverse properties, if you have a natural log and the e right next to each other, they cancel out, and your answer is just your x. There. So now I have this over here. Now to get my x by itself, I'm not dividing because the natural log of 6 is being added into x. So that means to get rid of it, I'm subtracting. So it's not natural log of 5 minus natural log of 6. It's not natural log of 1. You're actually doing natural log of 5, enter, minus the natural log of 6, enter. And when you do that, you end up with the natural log of negative 0.18. Making sure that's correct. And that is. All right. For example, for A and B, I'll give you the equations down below. I don't have that much time to explain it all, but there is a certain way for each one. So for the first problem, example A, they're saying this person's giving a penny each day, but they're doubling the amount. So I get 1 penny one day. Next penny, I get 2. Next one, I get 4. Next one, I get 8. I get 16. I'm doubling it every time. So when I'm doubling it, it's a penny again. They want to see how many days will it take for me to have over $1 million. So I have $1 million here. But again, we're referring to pennies. So $1 million, when I convert to pennies, it's actually 100 million. So what they did, they put it as a scientific notational form, just 10 to the 8th power. So if I move, remember the decimals over here, 1, 2, 3, 4, 5, 6, 7, and 8, so it's 10 to the 8th power. Now they're trying to solve how long it will take for me to have $1 million, and we're going to use the equation 2, and then n minus 1. So we have 1 day, we have 2 days, we have an infinite number of days, and we're always doubling that amount. So then we get 2 to the n minus 1 power is greater than 10 to the 8th. They said how long will it take for us to have more than $1 million, not under $1 million. So that's the greater than symbol. Now for here, to solve, we take the log of both sides. So log of 2n minus 1 is greater than the log of 10 to the 8th power. Now, we can go ahead and simplify. On this side, I have an exponent. I can go ahead and move my exponent to the front. N minus 1, log of 2. Remember, if the log, the base, and the number in front are the same, you can cancel them out. It's one of the inverse properties that we've learned before. So remember, the common log is always log base 10. So whenever you have the base and the number here, and if they're exactly the same, they cancel out, and you end up with the exponent itself. Now here, n minus 1 times log base 2, we go ahead and distribute them. So I have n log of 2 minus log of 2 is greater than 8. Trying to get the n by itself. Gonna have to move this over here. You add log of 2, so think of it as just fractions here. So then I have n log of 2. If I add those two numbers together, I think the book has a different way. This way will also work the same way. If you do 8 plus 2 and divide by the natural log of 2, that would also work out the same way. But just for the sake of my problem here, I'm just going to go ahead and work it the same way. But again, it will give you the same answer if you do this way. I just didn't work it on my calculator like I do beforehand. So here, what we're going to do is instead of actually separating them, I'm just going to divide both sides by the log of 2. So then I officially get the n minus 1 by itself on one side. So 8 divided by the log base 2, I end up with about 26.57. Then I can add 1 to both sides. And that means it would take about 27.57 days. And if you were to plug 27.5 in place of this equation, you're going to get something under $1 million. So what they did is they rounded it up. So for all of these, you're going to round up. So how long it will take? It'll take about 28 days or more for you to get over $1 million. So 28 days. Example B. So again, this one's like retail. So they're trying to sell a jacket. It costs $199.50, but they're going to take the price down 10% each day. And they said, how long will it take for the jacket to be under $50? So every day they're taking 10%, another 10% from the amount. So you take 10% of $199, it turns to a certain amount. And from that new day, from that new amount, you're taking another 10%. And it's a whole chain reaction. They say, how many days will it take for you to finally reach under $50? So therefore, I have 199.50 times 0.90, because that's what's left of the percentage there, times n for the number of days. And remember, it has to be less than $50. We're not looking for things that are greater than $50. Now, let's go ahead and solve for this. So for this, the first thing I would do is we're going to go ahead and take the log of both sides. So log of 199.50 times 0.90 to the n power is less than 50, or log of 50. Now, looking at this here, I have two things that are multiplying. I'm going to go ahead and separate them. So log of 199.50 plus the log of 0.90 to the n power is less than log of 50. We can get the n by itself on one side by moving this over. Log of 199.50, subtract that. Also, n is an exponent. I can go ahead and move it on to the front. So I have n times the log of 0.90 is less than, I went ahead and combined it together just so it can be easier instead of seeing all the logs in the end. I get negative 0.60097. I divide both sides by the log of 0.90. Log of 0.90. And then I end up with, and for this here, whenever you have, let's say, log base m, if you have a number that it's between 0 and 1, that means your log is considered a negative number. If you have a log that m is greater than 1, so that means it's going to be positive. So in this case, 0.90 is between 0 and 1, so that's considered a negative number. So that means your sign changes. Now, when it changes, I'm doing 0.60097 divided by log of 0.9, not 90. So when I divide that, I end up with 13.3. If you were to grab this number and put it in place of n from the original equation, you're going to get something under or over $50. So again, you round up. It's going to be about 14 days for the jacket to be under $15. Example 5, last one. This is where it deals with compound interest whenever you're trying to apply for a loan. You have savings account. You want to see how much money you're going to accumulate because of the savings of the interest in a good way, or it could be interest in a bad way. We have this, it's a standard formula. They don't have it, but I'll have it for your homework. This is a standard formula that you'll use to solve for it. A, consider the total amount, like your new amount. P is your principal, meaning your starting amount, so how much money you put into the bank. R is your interest rate, N is the year, and T is the number of times. So let's say, how long will it take for you to accumulate blank, blank, blank. So here, for example 5, I have everything written down. But here they want to know how much will my amount double from my original amount if my interest rate is 9% after let me read it. It says, how long will it take an investment to double, so from your original amount, doubling it up, to the value of 9% interest compounded quarterly? That means 4 times per year. So it's amount per year, meaning it's quarterly, so I'm going to put quarterly here. Meaning they're going to add it every 3 months, every 3 to 4 months here. So here, we're going to create an equation. So for my principal amount, I know it's already P. My A, my total amount, they said they wanted to double. So you know what we're going to do? We're going to put 2P in place of the amount because we wanted to double the original amount, which we have P. We don't know what the original amount is. Now, we have 1 plus R is the rate. So the interest rate is 9%, but we're going to put it in decimal form. So 0.09. 0.9 is 90%. 0.09 is 9. So N is how much they're going to put it in the money in your account, and that's quarterly, so that means 4 times per year. And then NT is 4T. So how long will it take for me to double my amount? With all this information, we go ahead and solve for it. So here, first thing I'm going to do, I can get rid of my P's. I can go ahead and divide them. So I divide them, I get 2 is equal to 1 plus 0.09 divided by 4 to the 4t power. I can simplify adding 1 plus 0.09 divided by 4. I ended up with 1.0225 to the 4t power. From this point, I want to solve for t. I can't just move it to the front without there being a logarithm. So that means taking the log of both sides. So the log of 1.0225 to the 4t power. Now you can move it to the front. There has to be a logarithm for you to move it. So the log of 2 is equal to the 4t times the log of 1.0225. You're solving for t. Divide. You can divide by 4 log of 1.0225, or you can do log, divide both sides, and then divide again by 4. But I'm just going to do everything in one step. 4 times the log of 1.0225. This will cancel out this, and then my t will equal about 7.78. And remember, it's quarterly, so on the book they have 7.25, that's the first quarter, 7.50, that's the second, 7.75 is third, 7.75 is more closer to the fourth. So this, they want you to round up because they want it to be double. So they don't want just about double, they want doubled or more of the amount. So again, that's why I always recommend you rounding up. So that means it's going to take about 8 years for you to double your amount with the interest rate. All right. If you have any more questions, let me know. If you need any of the missing assignments, let me know. Bye-bye.